Okay. Last time I was building the low-level parts of a pattern sequencer that's going to have a pattern language similar to what a number of other live coding environments have, in particular title cycles, because I like their pattern language quite a bit. So this is what I'm building, something that will be similar to the mini notation in title. And so what I built is currently a sequence, and the sequence consists of a nested set of subsequences, which can be either a single item, just a value to play, or what I'm calling a tuplet, which is just a list of subsequences. And then the sequence moves through those things based on a trigger signal, a clock, and a divider for that clock. And then every subsequence, for every item in the sequence plays every clock divider number of beats from the trigger signal, number of triggers from the trigger signal. And then if one of those items is a subsequence, the elements in that subsequence play within the space of one beat relative to the parent. So you can do basically tuplets like you would have in traditional music. So this part is probably working. I haven't actually tested it yet, but I think it's reasonable. And so the next step is to go into my parser for the live coding language and add support for this, because these sequencers they're qualitatively different from my normal node constructors, and so I actually parse them specially, and so I just need to add something to that parsing, and just to give you a sense of what that looks like, let's look at this. Okay, so this is the syntax I'm looking for. I'm defining a node, which is a sequence of these elements driven by a clock, and so the clock has a divider of 4 on it. So every 4 ticks of the clock, it will go 1, 2, and then within the third beat, it'll go 3, 4. So those will be half as long. And then back out on the 4th beat to the regular tempo of 0, and then loop back to 1. And so this is what I'm going to support. Currently, you could do this, and that would drive through that sequence in a loop based on the tempo, but it doesn't have any of these other concepts. So I'm adding those other concepts. So hopefully by the time I'm done with this video, that will run. Okay, so excuse me. Let's look at what I've got. So this is my current parser code for the sequences, and you can see it's emitting an older node that I had built called a sequencer, rather than this newer one, which is called pattern sequencer. So I'm gonna have to switch that. The syntax is going to be similar. It's going to be a string of characters that are not one of these dividers. Actually, I guess I can replace that with a node name, since I've got that concept now. In the previous video, I built out this reusable node name. Yeah, so let's do that. Okay, so it can be a node name. Followed by equals, and then the magic constructor that gives me the sequences. And then that is followed by an open square bracket list of numbers. So this will have to change, because in the previous step, it's just these raw values, and now I'm going to have to support this whole pattern thingy, comma separated, followed by a close thing. And then this will also have to change. Then there's the parameter, which is an expression that I'm going to treat as the clock signal. List of expressions. So I'm taking a list of expressions. What do I do with that list? That is the p-value here. Okay, interesting. So I'm confused by this because I know that this node actually only takes one input port, but the way I've written this, it accepts two, accepts two, accepts multiple input ports, and I think that's because I'm copied and pasted from a more generic version of this. So let's actually, while I have that in mind, let's think about that, because I know that in this case, I'm always going to have two. I'm going to have at most two, because theoretically I could patch them in later. I don't know, whatever. I mean, in other places, the input ports can have a default value that you don't necessarily supply when you call the node constructor, and then you fill that value later by patching to it. In practice, I don't actually do that. So I'm going to introduce a little inconsistency into my language by just pretending like that is not possible. I don't think that matters. Okay, and then if I'm doing that, this becomes non-optional. You must always have two expressions. In which case, this is now... I think this is going to go clock divider. I think that's how it's going to divide up those tuples. No, apparently not. Unnecessary parentheses around pattern. And this too many parentheses. Use correct. Still wrong. What does it think this is? Mismatch type expected string. Okay, so you're going to go in the other direction. So it's going to be like this. And then this. Mismatch types, expect expressions. Because I have used the wrong operator there. Use the right operator there, that's right. The wrong operator. So the star means throw away previous matches, require but ignore the previous matches. And then, so I wonder, maybe I have to bracket this, or group it. Mismatch type expression. I don't know what you want. Found why is this expression? This is wrong. And this is actually the clock. I guess that's the way it breaks down. Okay, cool. That's pretty fiddly. Okay, cool. So now I have a required 2 expressions, one for each of my input ports, a list of numbers. So now I have to think about what those are. They're not going to be numbers. They're going to be either numbers or subsequences. Whatever the numbers, what I'm calling items. So it's either a number or it's a subsequence. So let's figure out what a subsequence looks like. Subsequence is going to be a list. It's going to be very similar to this, actually. And in fact, this is going to be recursive. Because subsequences can contain subsequences. Which means I think I have to make another one of these. Subsequence, which is going to be a parser that takes a byte string and gives me not this, but a subsequence. And that subsequence is going to look like this, which is a list of either numbers or a subsequence. And since it's recursive, I have to use this call, which is part of the POM parsing library. But this is all being done through POM. POM, POM. So, 2 arguments. Call. Okay. Equal with the parentheses. Okay. So now this is going to be wrong because I need to convert it into a subsequence, which I'm going to do with map. I'm going to take that list, which is all I get. Subsequence, do something with it. And then the something that I do is going to be I'm going to build these in So I'm going to walk through these things. What does this mean? So this is... Oh, I can't do this, can I? It's a heterogeneous... Yes, I can. This list was going to be heterogeneous because it's going to return a floating point number or a subsequence as the item in the list, and so Rust doesn't do that. So instead, I'm going to have to convert this, which is fine because I was going to do it anyway. And what it's going to become is a sub. It's item. Okay, so now my list is homogeneous, which is what I wanted. And it is but it's still this weird recursive thing where it's potentially, subsequences of subsequences. But the only case I actually care about is if this list is one item long, then it is the subsequence, because it's either an item or subsequence. If it's multiple long, then I have to pack it into a tuple, and then that tuple becomes a sequence. Okay, so that's actually pretty simple. So if s len is greater than 1, if it's 0, is that allowed to happen? I think list can return it, can make it empty, in which case what I really want is a convert, I think. This is the failable version. In which case, I think if len equals len is empty, so this is invalid because the subsequence contains no items. And in that case, I'm going to return some kind of error, and I don't remember what kind of error it wants, so we're just going to start with an empty tuple and see what that needs to be, because I don't know. Otherwise, the list is going to be either one item or more than one item. So if else if len equals 1, so this is our simplest case, because in this case our subsequence is just that one item, and we just go since we're in a result world now. Just take the first thing, we're done. Otherwise, we know there's multiple items, in which case we need to build a new subsequence that's a tuple. But that's easy to do. So wrap in an OK, and we go subsequence tuple. And the tuple has more state than this. Let's see. What does its state look like? It is tuplet, not tuple. Okay, so its only state is actually its index, which starts at 0. So I could make a constructor, but whatever. I'm not going to bother. Let. And that is my list of subsequences, and then a index of 0. Okay. So that will parse me a arbitrarily deeply nested list of subsequences. Okay, so now I can go back down here. I don't care about that anymore. Parameters are the same, but R is all of this stuff becomes this instead. Okay. All right. Now I should have the name of the node, which I'm calling K for key, for no particular call it node name instead, and then a subsequence, and then the clock and the clock divider. Okay. And so this is no longer valid. And what it actually is it's a pattern sequencer. And what it takes is that subsequence. So now, previously I was taking an arbitrary number of inputs, but it was optional. So instead, what I'm going to do is I'm going to take my two inputs, which are clock and divider. I'm going to build mutable edges. Edges. It's going to start empty. This is not that important, but because I am casual about performance more often than I probably should be, just pre-allocate the right size. And then we're going to loop. So it's going to be edges. I know this is 3 items, not 2 items. Edges dot push dot extend. No, actually, I don't know how many items it's going to be because each of these expressions can expand into an arbitrary number of edges. Whatever. At least it'll be at least 3. No, I think it'll be at least more than 3. Whatever, it doesn't matter. Okay, so the first expression is clock, and that needs to connect to node name. Yes. At port 0. Okay. And then I'm going to do the same thing with the divider. Okay, so now that fills out all the information that I need to build this part of the subgraph that corresponds to the clock connecting to this node and the subdivider, or the clock divider connecting to this node. And now I can and then I add the piece that allows me to build this actual node that is the sequencer itself. Cool. Okay, so I think that's pretty close. It is unhappy about something here. What is that? Cannot move out of index. It says it doesn't have copy traits. And indeed it doesn't. Is clone. I should be able to consume S, I think. Whatever. Okay. That's gonna clone. I probably don't technically need to do this, but that is how it's gonna be. Okay. So that is maybe okay. Let's move to my test thing. So now I believe that this should work. So let's actually do a thing that will make sound. So we're going to go to sine wave, and it's going to start at a low value multiplied by this sequence. So this is going to play basically the harmonics of the harmonic series for 110 hertz. Well, times 1, times 2, times 3, times 4. Let's not do times 0. I don't know, just for kicks. And then we're going to play that. To the output. Okay, so that should make noise. And let's see if it does. Pattern, what do I call it? Pattern test. That's I think it's going to compile. That's kind of cool. Okay. That is for sure noise. It's not quite the noise I was expecting. so that with one value it's working. It's fine. So the first value seems to play twice as long as the second. So there's something wrong with my looping. And I don't know what that noise is. That seems pretty wrong. Like it's producing the wrong value even, which that's unfortunate. Oh, it must be switching back and forth real fast. Okay. I think that's what that is. So that sound is not actually one frequency playing, it's it vibrating between two frequencies. So that implies that something in my logic with the clock divider must be broken, which is not that surprising, but unfortunate. Okay, so it seems to be working for the one note case, the one item case, but not the others. So what would that mean? Here we go. Top right. Clock divider. So it thinks it needs to do a tick. If the current thing needs to do a tick, the current thing needs to do a tick if it's an item, which will be the case for everything in that outer list in my example. If the clock mod the clock divider equals 0. And clock mod the clock divider, I mean, maybe using the mod here isn't really safe because I'm in weird floating point world. No, I'm doing that mod as U32s. Is that wrong? What does my clock divider actually look like? I don't like that debug moves the value. In this case, it's a copy, so it doesn't really matter. But and then let me take this out. Fours and 12s. So that's definitely not what I'm expecting. So I think it should always be 12. Because I take the length of the outermost list, multiply it by this step, and that's my clock divider for the tuple that represents that outermost step, because it will then immediately divide it by 3. So what does that mean? So this I think should always be 12 in my example, and it's not. Or no, am I wrong about that? It should always be 12 in this branch, but not in the other branch. I think that's more accurate. And it's true. Okay, so it's switching back and forth. This is 12. This one should always be 4. For completeness, I'm going to prove that's true, although it definitely is. Okay, so that part's right. So then Yeah. Okay. Good. Okay. So that's all working. So then my clock is working forward to this, is ticking forward to the Schmidt trigger. And just double check I've got that right. When this rises and it's not triggered, I trigger it and I increment the clock. If it's below the threshold, I untrigger it. Okay, that's fine. And then I throw that clock into the sequence. Okay, so I think that's right. And then this guy is going to go, my clock, always an integer. In this example, at least my clock divisor also always an integer. In this case, always floor 4. So clock mod 4, if that equals 0, then I do need the parent to increment its index. Otherwise, I don't. Okay. Sub index. So if the current item told me I needed to increment my index in this tuple, I do. Okay. If my index is now equal to the length of the array, I move it back to the beginning. Yeah. And 2. So what am I missing? Something is wrong. And then, let's see, the way this is set up in the example, this value actually has no effect because the topmost level just ignores it because it actually doesn't have an index of its own. It's never going to move past the outer tuplet because there is nothing else. So the only thing that this can have an effect on is this. But that seems fine to me. Yeah, I'm not super clear on what's going on. Let's see what values the clock has when that tick actually happens. And that rollover happens. Maybe that's not what I want. No. Okay. So those are right, I think, right? It's, every 4. And then no, those are wrong. The clock is advancing by 4 every time it rolls over. But that's not what I expect. What I expect is it to advance by 4 for each item, a total of 16. Okay. What is wrong there? That sure is the same sequence it printed out last time. So that means every time this fires, which is firing at the right times, every 4, this also fires. How is that possible? Oh, I'm so confused. Yeah, but it's printing those many times. Something here I'm not thinking clearly about. Interesting. So you can hear in that weird bit where it's got the tone that's a complex timbre because it's moving back and forth with frequencies. You can see that was the moment where it like advanced really fast. So what is happening there? It has to be this is wrong, I think. Okay. So what does that look like? Not do that truncation. Oh, I have to do that truncation. Oh, okay. I think I see what's going on, and it is because I'm a little dumb. So what's happening is that this clock only advances every n frames or whatever, right? But this gets called every frame or every sample. Which means that when this is on a beat where the indexes should advance, it does that once every 100 samples or however longer than that, however long the length of those 4 beats is. But this gets called for every sample in that section. Every time it gets called, things advance. So what the code I've written above is actually expecting is to be called once per clock advancement, not once per sample. And I think that's the right thing. So what I'm going to do is I'm just going to cache that value. So okay. And so what happens is, in this case, only when the clock advances, I go the current value is equal to whatever that returns. So now the sequence is only getting queried for its state and possible state transformation when the clock actually advances. And then now here I just return the cache value, which maybe will be the same for many frames at a time, or samples at a time. So I think that probably just fixes it. Okay, that sounds better to me. octave at the octave, down an octave, and I think that's actually what we're hearing. Cool. Okay. So let's say I want these to be twice as fast, and then it to repeat at the 1 octave. Cool. And so there you actually hear that pattern. I can make this even faster. But something seems wrong here, because I should have 2 long and 3 short, but I hear 1 long and 4 short. Okay, so something's still wrong. Better, still not correct. And interesting that, like, this seemed to work, right? Dun 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 dun. So that seems right. But this seems wrong. Why is that? I suspect I've got some sort of rounding thing going on. Here. So in this case, in this example, I've now got this outer list, this outer tuplet. Each of these, this, and this whole thing, and then this. Each of those is 4 beats. This has to fit into 4 beats. So each of these things is going to be just slightly more than a beat. And I respect that here by making things floating point. I don't respect that here because I force it back to integer. So, here is what I actually do. And also this is probably incorrect, because I don't really know what's going to happen when this clock divider is some weird number that can't get properly represented in floating point and has, 3.333333 or whatever, what that mod will ever do. So this seems like something is probably wrong, but we'll see if it sounds wrong. Yep, whatever that is, not the right thing. So I'm not even trying to figure out what was actually going on there, because I'm pretty sure it's this. So, what I probably want here is to do like an epsilon. So if I take this is the absolute value of that, whatever it is, if that is less than some small number, then we're okay. Because it might be effectively 0, but not actually equal to 0, for whatever rounding thing. Yeah, that is not it. Okay. Interesting. Can I put multiple values into a debug? I don't know that I can. And then, what is this actual value? I don't really know. I don't think this is right. It is? Okay, cool. Good job, Rust. That is super not doing what I'm expecting. So my logic is just wrong. I'm not thinking about this right. So what do I actually want here? As my clock advances, I want to trigger on the first step where it is gone past. Yes, yeah, so I think sort of what's going on here is this is in the previous video I was talking about how I was going to do a clock divider instead of a clock multiplier because that was more complicated. But I think this is an example of why that's hard. Because now I need to trigger on a fraction of the outer clock. And I just can't. That just doesn't work. So I have to build the clock multiplier. Okay. That's fine. I actually think I have code for that here somewhere that should mostly just work. If I could remember where it was. So where did I need a multiplier? It was... whatever. I just gotta figure out how to do it again. Okay, so to do the clock multiplier, well, first off, let's think about what this now looks like. So now I'm just not going to have that. I'm going to say that by default, the outer sequence, the outer tuplet, will advance every tick. So like this. And then the inner sequence will advance in multiples. So this will advance 3 times in a tick, multiplied by, so the tick multiplied by 3, or the tick frequency multiplied by 3. Okay. So in order to do that, I need to keep track of how long my triggers are. And I could try and do something super fancy, but I think it's going to work if I work in most cases, if I just track what the time between the last 2 triggers was. And that means, I have I'm going to have a clock. It's going to be in floating point. This is still a little bit complicated. Let's see if it works then. Okay, this also means that I need to know how many seconds are in a sample. I have to respond to this signal, which is called by the framework when the sample rate changes, and lets me set this to a reasonable value. That gives me the number of samples, the number of seconds per sample, whatever, because that will always be set before the synth starts running, so I don't actually have to pre-initialize it to anything. Okay. I also need to know not just the delta, but the previous trigger. matters. Okay. So now what's going to happen is when I trigger, I also set the time of the previous trigger to the current clock. And I'm actually going to have to move the clock forward on every sample. And I'm not moving it forward by 1, I'm moving it forward by the number of seconds per sample. So this is a literal clock, actual time. Okay. And then the sample delta, trigger delta equals the current time minus the previous trigger time. So that gives me the number of seconds, which will be a small fraction of a second, the number of seconds between the previous trigger and the current trigger. And I'm just going to assume that that's static, which may not actually be true, but I think unless I'm modulating very quickly, I don't think it will matter. So I assume that every trigger, the triggers are evenly spaced, and that spacing is not changing. In practice, that's not a good guarantee, but we'll see if it works. Okay, so now this guy doesn't really care about the actual time. He cares about the number of triggers, but the floating point number of triggers. So he cares about fractional triggers. And I need to go back to doing this every sample. So I may actually have been basically right the first time. But that's fine. In which case, maybe this cache doesn't matter. Okay. So this is the real time. What I actually want is the number of triggers. And I'm going to base that on the current measurement of how long a trigger is. I think that's okay. And that's the wrong type, or whatever. Okay, and so now doing it this way, there's no reason to cache, so I can just return this directly. I don't need that field anymore. I don't need that field anymore. Okay. And now I need to fix this, because clock is no longer an integer, it's a floating point. And whatever that is. So now the logic here is going to change a little bit. No longer dividing, I'm multiplying. I'm multiplying the effective rate of the clock, which is... So I think that's fine if I just go clock equal clock times 5. I'm multiplying the effective rate of the clock by length of the sequence. I think that's fine. And then that becomes... I don't care about clock divider anymore. That's no longer a meaningful thing, I think. So this is if clock so if the fractional part of clock is small, then that means it's close to an integer multiple, a single, which is a single beat, and I should tick for the one item case. And here I am increasing the clock rate by the length of the sequence, passing that modified clock into the children, which I think is right. Okay. Why are you... Okay. Oh, right, because clock divider... No longer, it's not even input anymore. Right, I already made that decision. Yes, it's just not there at all. Okay, that might be it. Now that for sure is silent. So what does that mean? Something's not working. So when I guess I'm getting nothing, and why is that? Something about how I'm working the clock. So let's think about, if I start with a previous trigger of half a second, clock of 0, trigger delta, second previous trigger of 0. Yeah. I don't think this is it, but it could be just a weird number getting into the clock. Okay. All right, let's just verify that the clock is progressing, because I have certainly... no, this has to work, but whatever. What else? That is oh. Okay. Actually, let's keep this, because that sure wasn't what I was expecting. So I expect this to always print, and it was printing nothing, which is not what I expected. I think that implies this is not parsing. And why would that be true? Let's just verify that's true. And indeed, this is not parsing. Okay. So, that implies there is something wrong with this guy. And just double check what I'm doing here. Okay. So I have a node name, followed by equals sequence, and that should be fine. Just double check that my node name does what I think it does, which is any lowercase character followed by any lowercase character or a number or an underscore repeated 0 or more times. Okay, so that should work. So So I'm sniffling because I actually was just at work in the garden for a second, and there's a mugwort plant that I had to cut down because I am ferociously allergic to it, and it started to flower. But I'm still reacting to that. Okay. So let's see. So it's a name followed by a subsequence, and a subsequence is a square bracket. Ignoring that, and then a list, and it is a list of numbers or another subsequence, comma separated, followed by a square bracket. And okay, so there's some failure cases here. Okay, let's do a quick check. Does the simple thing parse? No. Because I forgot to change this. I removed one of these expressions, so now there is a single expression, but I didn't update that. So now there is only a clock, no divider. What is that, the third place where I made that mistake? Okay. And you don't like that because of this. Okay, so I'm gonna go back here and get rid of that because I don't care anymore. And then there. So that should be changing when it's done. Very slow. Why are they so slow? That changed because the sequences are still resetting their index every time I reload the graph, which I need to fix that. Okay, it's not just that they're slow, it's something's wrong. So, stop that. Okay. So, let's see. Go back to this. I just changed this. It looked right, okay, like right before, but let's just make sure that it's doing a reasonable thing. And actually, let's make sure that it's triggering. That's more interesting. So it is triggering, and the clock is moving forward. That is sure not moving forward fast enough, though. Why is that so slow? Because those should be in seconds, but like 1 alligator, 2 alligator, 3 of those are not seconds. Per sample rate. This is the right calculation, though, because it's... Oh! Because I'm dumb. So what's happening is I'm in it is moving forward too slowly. It's moving forward at 1/8 speed. And the reason is because I'm in control rate and not sample rate. So to fix, one of the ways to fix that is just to remember that this guy's going to get called once for every 8 samples. So I need to move forward 8 times as fast. Okay, it's still not working, but at least the clock is moving at the right rate. That is for sure a thing. Sometimes it works and sometimes it doesn't. That is sure not what I'm expecting. Okay, let's just see. Do I have these calculations right? So my trigger delta is the current time minus the previous time it triggered. That seems reasonable. The previous time it triggered gets reset to the current time. Also seems reasonable. I think that's all fine. So what do I do? So I'm going to take my clock, which is in seconds, and I'm going to divide it by the time per trigger, which will give me in triggers, but scaled to the current trigger duration, current trigger delta. So as the triggers get far apart, that number goes down. Further apart, trigger delta gets bigger, the number goes down. Okay, so that's in the right direction. So I think that's correct. So I'm doing something wrong here then. Okay, well let's just do, go back to this. I think this also doesn't work. Let's just double check that this sort of base case does indeed work. Oh, that is super weird. Because it is triggering sometimes, but not all the time. Why would that be? Okay. So I come in with my clock in triggers. I multiply that by the sequence length. So as the sequence gets longer, time is going to appear to pass faster. Is that what I want? Maybe that's not right. Because this cares about time within the current beat, not total time. Position within the current beat. So what do I... Okay, so if I assume that the clock is in ticks scaled for the parent. So at the top level, that's my base tick length. What I actually want to know is I want to know ticks. Okay, maybe that's my problem. I don't want to know total ticks. I want to know ticks since this tuplet became the tuplet of interest. Okay. I think that's right. So what it actually is it's not this. It is this. It's time since the last trigger. No. that's not right. Because that doesn't work. No, that doesn't work. That's just confused. Okay. So what am I missing? Caused by macro. What? Ignores token. Macro expansion. Caused by the macro expansion here. Source macro. The usage of print line, likely in an invalid item context. Likely in an invalid item context. What does that mean? Oh, motherfucker. So this is, as I said before, I'm using Cacone, the editor, and I love Cacone, but it has one really serious problem, that when you undo, it scatters selections all over the file sometimes, in places you can't see them, and then you start typing and you're editing things that you can't see because they're often like completely off screen, and it is the most frustrating thing. It's like my number one mistake with Cacone, other than just basic typos. Okay. What am I seeing? So this is moving forward. That is moving forward, but not ticking. Certainly moving forward fast enough to tick. So I'm doing something dumb here. What am I doing? The clock that's coming in is that thing that's moving. Okay, this is garbage. I don't know why I thought that was a good idea. So what am I actually checking? I want to look to see if the clock has crossed an integer boundary since the last time this ticked. Do I have to keep a clock inside the item? Seems excessive. I think I could do that, or I could special case it and keep a clock inside the tablet. Yeah, whatever. Just do it. So what that's going to be is last trigger. If the then we need to trigger again and left. This feels super wrong. I'm doing something silly. But I'm honestly not sure what it is, so let's see if this works. That's not interesting. Oops. That's not interesting anymore. And then when I build these items in this guy, which I do here, I need to initialize that call to something. It feels super weird to have a clock in every item. I don't. And indeed, it is obviously not working, so. Stop that running. Okay. I'm thinking about this backwards somehow. What do I want to track? So, what I want to track is I want to track the number of beats. So in the outermost layer, I want to track the number of beats total from that clock that's passed in from the outside world. And every time a beat happens, I want to increment the index in that outer tuplet. And then so I could do that in the tuplet itself. And then if there's a subtuplet, I want to make the beats move faster, so that every beat at the outer layer is a number of beats that equals the length of the subtuplet in the inner layer. And that's what I'm trying to do here by expanding that clock. So I guess what I want is, I'm thinking about this as a clock, but that's not actually what I want. What I want is a delta. And so that means you actually is actually a clock. And I drop the delta into that clock, and then if a beat has passed, then I'm going to reset the clock to 0. And so this is longer clock. Now it's called delta. Now it's called DT, excuse me. Up here too. And here. And then down here, it is the delta in beats. Yeah, okay, this still makes sense. Okay. So then it is guess I could be building this in debug mode a little bit faster. Okay, that is not beats. So those are not seconds, they're beats. Gotta remember that. Beats. Trigger delta. So this is going to be. Delta should always be between 0 and 1, basically, if the trigger time is consistent. Because this will be between 0 and trigger delta, and then 0 and 1. Okay. And then now it should be between 0 and 2, because I'm multiplying by the length, which in my example is 2. And here, let's just double check what dt actually is. This should be, I think, always the same. And it sure isn't. That is not the same at all. Okay, why is that? What am I doing wrong? dt, so that sequence length is certainly not changing. So it has to be changing here. And it is, okay, it's changing because time is moving. So what I need is not between the previous trigger, but between the previous sample. Right, okay. And so what this is actually is not that, it is that. So I'm just thinking about it backwards. Because it's not the time since I last triggered. Now I'm doing it but these are blocks of 8 samples because I'm at a control rate, but every block of 8 samples. Okay. Okay, aside from that blip at the beginning, which I'm not sure about, that seems more or less right. Let's not go that quick. Huh. It was... Maybe that's because that's the problem I was expecting with changing the size of the speed of the trigger. So that's actually going to be an issue then, if it takes it that long to adjust. That's too bad. Okay, well, ignoring that for a second, let's just see if this other part works. No. Oops. Typo. Okay, I think that's right. So that's the sound I'm expecting. awesome. However, the time that it takes to like come up to speed, not awesome. That's not going to work. So, oops, that's. Think about that. So, so the problem there is that when the graph gets loaded, which happens when this gets recreated, which happens every time the graph loads, that's a separate issue I need to fix. My initial trigger delta is 0.5. So I'm assuming a 2 hertz clock. But the actual clock may or may not be 2 hertz, and it may or may not be in a phase where it's going to... it may not be in a phase where it basically just triggered at the start and will not trigger again for half a second. And if it's out of phase, which it almost certainly will be, then it's going to appear for 2 ticks, that the actual trigger delta is shorter than half a second. So I think that's why we get that little doo at the beginning, because it's misunderstanding. So I am sure that there is a standard way to do this. Obviously, I could do some calculus on the rate of change of the input signal, and that would probably, I'm sure that's what a real clock multiplier is going to do, something like that. Because then you could measure the frequency in less than one cycle, I think. If you assume that it's like a sine wave. But I don't want to figure out how to do that. Wonder. I even have that file open. I wonder what happens if I do this. So if I just make this change fairly slowly. Okay. That's actually not too bad. You can hear it speeding up. So it's really just that blip at the beginning that's a problem, so long as the trigger signal isn't changing very much. That's basically what I would expect. And since I kind of expect in practice my tempos are pretty stable for the most part, that's not a thing I'm going to fiddle with too much. Really all I need to do is fix is a first pass. I think I want a better solution in the long term, but as a first pass, all I really need to fix is that initial bloop loop, which has to do with this getting reloaded. So I can live with that on first graph load, or when I first add this node, at least for the time being, but not when I reload the graph. So I need to fix that. So that means that in the places where I interpret this, what I'm doing is I'm building a brand new pattern sequencer, which has got like a garbage clock in it. That trigger duration is garbage. So what I need to do is I need to go where I interpret this and actually build the real node. exactly is that? And not in process, and reparse probably. And what I'm looking for is, okay, that's fine. I clean up. Changed. I add box to node. Oh, this is going to be hard. Because at the point where I'm doing this, these nodes actually have they're in a type erased box. And so the only thing I know about them is that they are an implementer of the node trait. I no longer know that they're a pattern sequencer node. But the node trait doesn't have any of this stuff in it. It's only the pattern sequencer that does. So I may not realistically be able to fix this until I have a more general solution for persisting the state of nodes across graph loads, which is a thing I've been thinking about for a while, but haven't actually done. Okay, I'm going to take a break and think on this problem because I'm not sure what to do. Okay, having thought about this for a few minutes, I think the idea of maintaining the node state it's just too hard. I can't do it. I mean, I eventually I want to be able to do it, but that's way beyond the scope of what I'm trying to do now. So I think what I'm going to do is I'm going to remove the need for a bunch of this stuff, and instead of having a arbitrary clock signal, which would be nice to have because I can put it in whatever oscillator, and it's consistent with other modules that I have. Instead, what I'm going to do is I'm going to take a desired clock frequency. So this is as if I was running a sine wave clock. This is the frequency it would be at, and that's actually my input. At which point I no longer need to track a clock, or the Schmidt trigger stuff, or the trigger delta, or the previous sample. All I need to know is how long per sample, and the sequence I'm configured with. So it's going to make things simpler, but inconsistent and less flexible, which is, I don't know, just the way it is. Okay, so now I no longer cover any of this. And all that matters is that I know how much time has passed in my delta. And then I need to know how many triggers per second I want, which is this frequency. And so I need to do that conversion. How do I do it? So to get the number of triggers, this is the number of seconds that have passed. This is the number, so per sample is the number of seconds that have passed. Frequency is the number of samples per second that I want. And so if I want 200 samples per second, then I want to multiply. Okay, I think that's right. Okay, so that gives me the fractional number of triggers that have passed since the last time this method was called. That's my delta T. And this is dead code now. Okay, and here none of this stuff changes. Okay. So I still have, like, I'm going to have a weird blip every time I reload because the indexes are all going to reset to 0. And that is unfortunate. But again, without dealing with a more general solution for node state, I don't think I can fix that. So that's fine. And then, so here, no longer using tempo, and instead I'm going to say I want 2 triggers per second, 120 BPM. And this should work. We will see. Okay, that sounds about right. So now I should be able to slow that down a little bit. And that response is instant. Previously I was getting that weird jitter as it changed, so that's good. And I should be able to go like, something like that. Okay. And so now I should hear a blip when I write the file, but it should, quickly sort of get back into sync. So I go blip, and you hear it. Because it starts over the indexes. Okay. So I think the time is coming when I'm going to need to deal with that problem. But right now I think I have what I set out to do, which is to have this sequence with this flexibility to do, whatever I want in terms of nesting. Okay, cool. So I think that works, and I'm left with some problems for the future, but I am done for now.